Good morning, everybody. I am Parthabotim Bhattacharya, faculty from P. N. Das College of Department of Chemistry. Today, I am going to discuss the topic, which is very interesting topic, known as chemical kinetics, which is taught second semester. The topic covers the following points. The points are definition of chemical kinetics, rate of reaction, rate constant, different type of order, molecularity, pseudo reaction, activation energy, and Arrhenius equation. Okay. Now, first of all, we should know what is chemical kinetics. It is a description of the rate of chemical reaction. It occurs biological systems such as microbial metabolism and different inorganic and organic chemical reaction. Now, what is the rate of reaction? You can see the graphical representation of rate in this PowerPoint presentation, and mathematically we can say that rate is change of concentration of reactant or product by change in time. Now, we should know the rate law and rate constant. The rate law is a law. The law states that the concentration of reactant is directly proportional. The rate of reaction is directly proportional to the concentration of reactant in a specific time period. And rate equals to K into two concentration terms with their power. K is the rate constant. Now, we want to discuss the order and molecularity. Molecularity is minimum number of particles or atoms or molecule taking part in a rate determining steps. It is a qualitative concept. It cannot be determined experimentally. But order is quantitative concept and it can be determined experimentally. From the rate expression of any chemical reaction, we can determine order. Order may be first order, second order, third order, zero order, or even reaction may be fractional order. Zero order, it is a chemical reaction where rate does not vary with increase or decrease in concentration of the reactant. The graph of the zero order reaction is given in the PowerPoint. Decomposition of ammonia on platinum surface is example of zero order reaction. Then what is first order? A first order reaction can be defined as chemical reaction in which reaction rate linearly dependent on the concentration of only one reactant. Okay. Example is dissociation of SOCl2 into Cl2 and SO2. Second order, it can be understood that second order reaction are chemical reaction which depend on either of the concentration of first two order reactant or concentration of one second order reactant. Now, we should know the activation energy. The activation energy can be explained on the basis of Arrhenius equation. The equation is K equals to A e to the power minus EA by RT. K is rate constant, A frequency factor, EA is the activation energy. Okay, and our molar gas constant capital T is the absolute temperature. The minimum amount of energy required more than that of average energy for a reactant to form the product is called activation energy. And graphical representation of activation energy is also given. So this is the beginning and most preliminary concept of chemical kinetics. In the next video, we will discuss a detailed mechanism of first order, second order and activation energy. Okay, thank you.